Yeah, just apologies that I couldn't be there, and thank you very much for the opportunity that we can present at the forum, and I hope that you will find the information valuable, and please don't hesitate to ask any questions.
We'll play the video now.
Sandvik Mining, world leaders in the provision of automation systems and equipment. The Northparkes E48 automation project demonstrates key successes in mine automation and the Sandvik AutoMine product range. Northparkes Mine is located 27 kilometres from the town of Parkes in central New South Wales. The underground copper and gold mine processes ore to high-grade copper concentrate on site before being transported south to Port Kembla and shipped to international customers. Sandvik and Northparkes Mine have developed a successful relationship over many years working together. Currently working toward 100% automation of the mine, planning for additional automation and future projects. Sandvik AutoMine Loading is a comprehensive solution for improving safety and efficiencies of underground mining operations. It is a flexible system which can be adapted to the unique working environment of individual operations.
At the beginning of the project, we investigated what automation packages were available to us, and Sandvik's AutoMine was the only package that met all our needs and was the only true mass mining production system.
It's got the loader automation side, the traffic management and the production management side, and the interface to our SCADA system. So that's come together and is now working well and seamlessly.
Working in collaboration with individual customers to achieve improvements in safety, productivity and peace of mind.
So the key business driver for us to automate the loader fleet was to increase the utilisation, and we do that by being able to operate across shift change and through blast clearance times. It means we get more tonnes out of the mine. More tonnes means more copper produced.
The ultimate goal for us is to have remove the operator from the hazardous working environment, be able to maintain the machinery at a lower cost and also increase production, increase machine utilisation.
Key drivers and benefits of Sandvik AutoMine include safety and health, improved working conditions, production management, improved utilisation, and lower operating costs. A key benefit of Sandvik's AutoMine is the increased safety and improved working conditions achieved for operators.
We consider the highest level of international safety standards from the concept phase, design phase, testing and commissioning phase through the whole life cycle of the system.
We remove our operators from a hazardous environment, which involves exposure to vibration, dust, noise, and we bring them into a controlled environment in the control room, which they really enjoy.
Sandvik's AutoMine removes operators completely from the potential hazards of underground mining.
The new system does a lot of the thinking for you, and it's a lot easier from up here, yeah.
So now we can come straight in here, there's no travel time, everything's set up for us. We just come in, sit down and get to work within a few minutes really.
Sandvik AutoMine Loading achieves productivity improvements. This includes the ability for single underground technicians to operate multiple loaders simultaneously.
All we have to do is bog the draw point, we'll send it on its way, it'll get to the ROM and tip by itself automatically, and it will turn up at the next draw point that's needed.
Increased productivity is also achieved through efficient use of machinery.
Our materials handling system don't see the big variation in levels when there's no one here, and the crews don't need to rush down and get into it hard to fill the bins. We can plan and be a lot more strategic about how we draw from the level.
Sandvik work diligently to ensure the ongoing support of its systems and machinery through a commitment to local, regional, national and international support structures.
With our service contract, we maintain all the mobile equipment to do with the production fleet, as well as now the automation infrastructure and the onboard automation equipment on the machine. We work around the clock, 24 hours a day, 7 days a week, 365 a year.
The success of Sandvik AutoMine Loading at Northparkes Mine is the beginning of much broader implementation for future projects.
We're looking to a 5-fold increase in production from Northparkes mines. We're going deeper, it's lower grade, we need to be smarter about the way we do it. So for us, automation is a key enabler for us to be able to get those tonnes out of the mine at a lower unit cost. For the rest of Rio Tinto, as we transition from open cut operations to large underground block caving operations, they look at Northparkes and the performance we have here to see what they can adapt to these larger block caves in areas like Mongolia and in the United States.
So one of the great advantages is we've had Sandvik on site for a long time. They know our systems, and certainly the regional guys, the Aussie guys, have been absolutely fantastic. They're as motivated about this technology as we are. So as we've come up to challenges, it's been a combined effort to get past them and make the system as good as it is.
Hello.
Hi Peter, we've just finished watching the video.
Okay, sure. So guys, if we can just go to slide number 2 in the presentation, and I'm just going to briefly run through this. Obviously pertinent to Sandvik with regards to our products and technologies is our safety and our vision towards safety. And we also understand that throughout this whole process that people are the greatest asset to our company when we develop and also introduce new equipment and new technologies into the market. So if we can go to the next slide, number 3. So for us in Sandvik with regards to the future of automation is obviously that we look at what the current demands in the markets are right now. And the greatest demand in the industry, as we understand it, is with regards to safe mining. Mines are getting more complex, they are getting deeper to mine, more dangerous to mine. So we need to find ways to do this more effective and more safely. But we also understand that people are the most critical link in introducing the new technology and in the success of automation. The people need to embrace what you deliver at the end of the day, and they need to be willing to work with it. Another comment is just that we also need to invest in the personnel and make sure that we get the right people for the job. Mines of the future are not going to look anything like the mines of today. And somebody once made the comment that we really need to start investing into more geek-friendly mines. Mines are going to need people with different skill sets. We also need to find ways to mine low-grade mines more cost-effective. Then with regards to Sandvik's approach is that we always follow close collaboration with our customers. Whoever the customers are that we deal with in the automation space, we make sure that we understand what their requirements are and that we give them what they really want and what they really need at the end of the day. And that also includes our suppliers as well as the industry legislators with regards to the functional safety aspects of system integration on mine sites today. Another objective is also that we understand that in order to achieve real automation, we need to automate the entire mining process and not just a part of it. Currently, OEMs are focusing on automating certain aspects or certain processes within the mining process. But in order to achieve the full autonomy, we will need to basically automate the entire process. But we also understand that it's going to take a few steps in order to get there because the technologies are not there yet in order to implement that. The focus is also on equipment autonomy, on the mining process, and also on data management at the end of the day. So if we can go to slide number 4. What this slide basically says is that the first approach for Sandvik was that we understood that with the various products we've got out there and with the various suppliers that we were dealing with in the past, that the only way that we could have a common integration of automation is to have the same platform across all the products. So in the last 2 years, what Sandvik has done is basically we looked at the products out in the market, and basically what we did was we established a common automation communication platform system so that we can use the same technologies for automation that we use in the underground and also apply that in some areas to surface, and vice versa where it is possible. So that is basically the first step, was the integration of the entire product range. Slide number 5, which talk about the future, is just also an indication of the fact that we've now got the what we call the SICA platform, the Sandvik Integrated Control System platform. It's now been implemented across our product range, and with that currently we are able to do full equipment monitoring, we are able to do remote control, we are able to do fleet management, process management, and in the very near future also proximity detection. So that is the focus for us in the near future. If we look at slide number 6, these are just some of the products under the Sandvik AutoMine offering. And the first one is AutoMine Loading, which is basically automated loaders in the underground environment. AutoMine Hauling, which is automated trucks in the underground environment. AutoMine Drilling, that is both for surface as well as underground. AutoMine Crushing and Screening, AutoMine Process Control, AutoMine Draw Control, and then AutoMine Light, which is single machine automation technology that we have out there. And we also believe that we currently have the most comprehensive offering in the market today. There's always a lot of talk about the benefits of automation, and that's what slide 7 is highlighting, is that the true benefits of automation cannot be ignored. And first and foremost is safety. If you have no personnel around the operating equipment, you obviously have a great improvement in the safety statistics. Now, we've implemented our first systems in 2004 overseas in South America and South Africa. And basically, since that time, we've had 0 LTIs in those areas. So the biggest benefit of automation is safety. Continuous production, obviously, the higher utilization you have, the longer operating hours, the more tons you can produce. Real-time production reporting, that is about data. At the end of the day, the data is also very, very valuable to your production and your maintenance people out there. And then also full real-time visibility of your assets and of your resources. So management can now see, and the mines can now see, where the equipment is, what the equipment is doing in real time, and whether it is performing as it is planned to perform. So the visibility aspect is there as well. And then also fully automated traffic control, where you've got more than one piece of equipment in the same area. Some of the other benefits are that people with disabilities are also now able to work on mine sites. That previously was not the case in those particular roles. And then also people that are injured, that are supposed to be on light duties, they can also now operate equipment because they're actually working from a control room environment. And then the last point there is less damage to equipment versus tele-remote systems. So the autonomous systems always perform, or let the equipment perform within certain design parameters, and basically that is a major benefit over manual operations as well as tele-remote operations. The video that you just saw on that slide number 8 is just about the case study of Northparkes Mine in New South Wales. That is basically a project that was initiated with Sandvik in 2007. At the moment, we've got 6 autonomous loaders there, 4 production zones, and 24/7 operation. What basically forms part of the system is real-time production recording and reporting, which gets updated on a 24-hour basis every day, and then also real-time condition monitoring and reporting to assist maintenance crews to look at the condition of the equipment that is actually operating underground. Automation also allows for production over shift change on that mine, so they don't have to clear the operators or the machines for blasting clearance, and there's also no travel time for the operators underground. So it's all on a sea change, hot sea change basis that is currently performing. The system also fully complies with the supplier obligations under the AS 61508 standards for functional safety. So we've done a major effort during the design of the system to make sure that we have all the parties involved from the mine as well as the legislators in New South Wales to make sure that when we implement the system will be acceptable and can be signed off according to the standards. If we look at slide number 9, that talks about the success factors at New South Wales. First and foremost, again, you need to have a very strong safety culture when you use autonomous operations, autonomous equipment. And then the second most important point is the acceptance of the technology. People need to understand what they work with. They need to understand the benefits of the systems and the technologies that they're dealing with. And in this particular case, Northparkes had very good change management processes in place to be able to move people from a manual production environment into an autonomous environment. Then mine operations acceptance, that's basically the same thing whereby not just the mine operators, but the people that are also doing various other tasks on the mine need to understand what the automation is all about. In Northparkes' case, the mine was actually designed for autonomous loaders, so that was a great benefit when we started implementing the system. They've got fully concreted roadways underground, and although it's expensive to lay out fully concreted roadways, the cost savings benefits in terms of tyre damages, equipment damages, etc., in the long run far outweighs the layout costs. Also, the system rollout plan to meet the production requirements for automation was done in detail, and we also ran various simulations to make sure that the equipment that we're going to implement, as well as the technology, would be able to produce what they're expecting to be produced. And then another factor is persisting with the technology. A lot of times when new technologies are implemented and you go during the teething phases where things do not go well, you know, customers and mines would like to revert back to the way that things were. And in Northparkes' particular case, you know, they persisted with the technology during the teething phases, and now that system is basically in full production after about 18 months. System reports are fully visible and easy to interpret. In Northparkes' case, they also had the first female loader operator that's now basically an operator under the autonomous system. Sandvik also got a full maintenance team on site. There's also a continuous optimization strategy that's been rolled out. And then we are working in close collaboration with Northparkes to develop future products for their automation technology. Now, if we can go to the next slide, there's off-earth mining transformation to automation. I think it's fair to say that the challenge for the OEMs at this point in time is that we don't fully understand what is meant by the term off-earth automation. What is off-earth mining equipment going to look like at the end of the day? Obviously, we understand that mining equipment to do off-earth mining would probably not be the same as it's implemented today. You know, will it be loaders? Will it be drills? Will it be something else? And thereby, we will need to work more closely together with people that are setting the benchmark in these areas. The first thing that will require is, first of all, a cultural change within the OEM organizations, but also in the mining companies. And then also to fully understand what the applications would be. And these learnings are not any different from what we've experienced when we did the automation systems with our current customers. We also need to understand and improve the capability of the technology. Will it be similar technologies to what we are using today, or is there going to be an entire step change into new technologies? The first thing, well, another thing that we also realize is that it is not a plug-and-play process. You know, it's different products, it's going to be different environments, we will deal with different cultures going forward, and then also the rate of technology evolution will affect the integration of future technologies into future mining practices. Implementation readiness, when do we need to be expected to be ready in terms of you know, where we are heading with off-earth mining, operational readiness, support readiness. How are we going to support equipment that's going to run, you know, somewhere else on another planet, for instance? The one aspect that's always a challenge with autonomy is not so much the operators, but more the way you support the technology and the reliability of the technology. And then also perception management, people's perception with regards to off-earth mining. In the current atmosphere, we do have challenges with regards to people thinking that autonomy or autonomous mines will never work. Autonomous mines is something that is still far away in the future. And we need to start working on that perception. We need to start changing that perception. And then also, as previously mentioned, change management and also the need to persist with the technology. And then operations and mine owners and technology owners need to take their ownership at an early stage. The next slide refers to some of the AutoMine operating sites. So as you can see, it is globally represented at the moment. In Australia, we've got 4 mine sites where the automation technology has been implemented. And there's various others online over the course of the next 5 years as well. And I would like to take the opportunity to thank Rio Tinto Northparkes Mines for the information that we could share today, as well as Newcrest Ridgeway Deeps and Cadia Gold Mines, and then also Rio Tinto Argyle Diamonds. I am aware that we are pressed for time, so that's why I went through the slides quickly. And I would just like to end off by quoting Henry Ford, which one day said, if I had asked the people what they wanted, they would have said faster horses. So it's not always the case of giving people what they want, it is giving people what they really require to be more effective and work more safely. Any questions?
Thank you, Peter.
That was really interesting, Peter. Something I wanted to comment on, which I've heard satellite people talk about a lot, is that changes in technology and systems on Earth can happen very rapidly, but once you have assets a long way away, your capacity to change them is very limited. So you have a kind of disjunction in timeframes between stuff in orbit or on other planets and the things that are changing on Earth. Is this something that you've thought about in putting this stuff together, and can you make any comment on how that might work?
Can you just summarise that question just briefly? I was struggling to hear you.
If I understand correctly, I guess Alex was asking, like another technology is rapidly developing and how mining equipment companies can cope this fast, rapid development. No, I misunderstood.
Sorry, sorry.
Maybe you comment.
Oh, okay. So what it was about was, so you've got stuff that's being operated on Earth, where technology can change very quickly and all other kinds of things can change very quickly and you can incorporate that. But you're kind of hindered by the fact that the stuff, the assets in orbit or on another planet can't change. So you can't, there's a massive disjunction between aging equipment that you can't replace or maintain and the things you can do with the stuff you've got on Earth. And I'm just interested in how, like the satellite implications of that, people have put a lot of thought into, but the mining implications of that, I guess I was interested in hearing your thoughts about that. Does that make sense?
I think the easiest way for me to answer that is that where OEMs in the past, and when I say OEMs, original equipment manufacturers like Sandvik, Caterpillar, etc., in the past we had departments within the companies that would develop technologies for autonomy, new control systems, etc., and I think the shift change that needs to take place there, and we do realise that, is that there are other companies and other people out there that do the technology better. So we need to find a way to integrate those technologies into what we would be offering in terms of the future and how we're going to mine the future, etc., etc. So, but you are right. I mean, once these technologies are out into orbit, I think the biggest challenge is going to be how are we going to maintain this? How are we going to maintain this? And how are we going to ensure that whenever we need to do an upgrade, because there will need to be upgrades, we understand that, and you will experience software bugs, etc., that we can basically deal with the upgrades at a level that we can do remotely. In other words, software upgrades, etc., and that's all part of the optimization process. But honestly, it's a very good question, and I really don't think there's a quick and dirty answer for that one.
Thank you, Peter. But just following up one question from me. As I'm working at the University of New South Wales School of Mining Engineering, we have very good relationships in education and research with Sandvik as well as Northparkes Mines, as you know.
Yes.
But my question, you mentioned that the skills need to be upgraded when you apply to full automation, which you've done in Northparkes. So as educators, what is our role to be, how can we be prepared for this in the universities?
All right. I'm going to ask a very simple question. If we have somebody that needs to be trained up in the role of an automation system specialist, what is out there currently that we can train these people with? We've got there are currently, as far as we are aware, there is not really any courses out there at any TAFE or any institute where we can send a person to basically get trained up to become an automation technician or an automation engineer, etc., etc. I think the closest thing that we've got at the moment is probably in the area of mechatronics engineering. And probably a good idea would be if we as Sandvik sit down with you guys and say that this is what we currently have in terms of technology offering, and this is where we need to be with regards to the way that we need to maintain this. Because at the end of the day, what's happening out there in the real world is that mines, OEMs are taking normal technicians, they're taking normal engineers, and they give them upskill training in order to perform those roles. But there's not really that one package where we can sit people down for a period of 12 months, 24 months, whatever it might be, and once they're finished with that, we can send them out in the world of automation, and they would be able to do optimization, maintenance, support, etc., etc.
Sure, definitely, because we're discussing already with Sandvik. So currently, University of New South Wales School of Mining Engineering and Mechanical Engineering thinking to create a new double degree program, which I can't announce now, but we, already.
Well, as soon as you know, please let me know as well.
Yeah, definitely. Thank you. Any other questions? Yeah, better.
Yeah, hi. So my question's a bit more about, I guess, a bit more of a mining style question. And you talked about your Northparkes site where there's a lot of people there that did have the automation knowledge, and they're all enthusiastic about the technology and the companies behind it with the operator acceptance and the safety culture. But how do you deal with sites that aren't quite so enthusiastic about the technology and don't have all the skills on site and aren't maybe looking at all their metrics? How do you encourage them to uptake the technology?
It's at the end of the day, it's a step implementation process. So we've also got another approach to this in the sense that we understand that full autonomy might be a bit overwhelming to some areas of the mine industry. And so what we've done in other cases overseas is basically we implemented the manual production or the draw control side of the system first. In other words, all the hardware arrives on site, the hardware gets installed on the machines, you still have manual operators inside the machine, and then basically through that you just do the production monitoring, the condition monitoring, etc., etc. The maintenance guys, they start getting the knowledge on how to maintain the stuff, how to fix it, and then basically after a period of time you start integrating the automation side of things where you take the operator off, but he's already familiar with what the system does because he could touch it, he could see it, he could feel it, and then basically taking him from underground, putting him into a surface control room, for instance. For them, in the majority of cases, that's also a motivating factor to come to work every day. So there's a few ways in which you can approach this, but that's the one way that we've done it in the past, is to first go for the manual production monitoring as well as the condition monitoring side of things. Make sure they see it, they touch it, they feel it, they understand what it's all about, and then you move on to the automation.
Okay, thanks.
We got one more question, quickly.
With space systems, you find that the computing hardware and the sort of stuff you can run your software and systems on is very, very limited compared to what you can have on the ground. For example, the rover on Mars that's got there just recently has a processor that is slower than a desktop PC from 1999. How would you deal with that? Because of the radiation hardness and all the things, the conditions it has to work.
I mean, that's a very good question, and that comes back to what I said previously, is, you know, what would be the strategy during the design phases on how we're going to do optimization. I have to be honest, I mean, Sandvik and us within Sandvik at this point in time, you know, we're not the experts in off-earth mining. It is a very interesting field to us, and it's something that we would like to learn more about, but I do believe that some of the processes that we've gone through will add value to the way that you're going to approach off-earth mining as well. And one is the strategy for optimization, because that's what we're talking about here, is that where we've got limitations with the current technology, what used to work 5 years ago, 3 years ago, is not the best on the market. So how would we be able to improve and upgrade that remotely? I mean, that's the question. Sorry that I couldn't give you the answer.
It's not an easy one. Anyway, thanks very much, Peter. Really appreciate it. While you are sick, you know, you were with us. Really, I hope you get well soon.
Thank you very much, and thank you for the opportunity. And again, I do apologise for not being there.
Thank you.
Appreciate it.